Hello, everybody, and welcome to math class. As I make sure this is straight, there we go. Hello, it's Taco. It's good to see you. Happy Monday. Let's get right into it. Thousandths place today. In our study of decimals, our intro to decimals, we've been focusing mainly on the tenths and the hundredths place. Today we're going to add the thousandths place. Concept is essentially the same. We're just going another level over to the right, meaning we're going 10 times smaller than a hundredth. Essentially, if we took a hundredth and we divided it into 10 pieces, we'd end up with 10 thousandths. Okay, there's what you're going to need, the usuals, something to write on, something to write with. And then today's I cans are as follows. I can understand that decimals are equal divisions of 1 organized in groups of 10. I can name and write decimals to the thousandths place. All right, so let's get into it. Like I said, the thousand, oh, hello, hold on. I'm going to change this banner because it's going to bother me otherwise. That's not the thousands. We know all about the thousandths. We're talking about the thousandths place. There we go. Put that in the middle. Lesson saved, am I right? So when we're talking about place value, as we do, we're always going to be talking about multiples or divisions of 10. Okay? 10 ones equals 110. Likewise, 110 or 10 divided into 10 pieces equals 1. Okay? Each piece equals 1. And with our decimals, same rule applies, right? 10 of one group makes 1 of the next group to the left. And 1 of the next group of one group can be divided into 10 of the group to the right. So our next place with the tenths and the hundredths is the thousandths, or the 1,000ths if you want to be more specific. Okay, just like 10 hundreds equals 1,000, right? Same relationship, except now it's kind of in reverse, right? Where 10 thousandths equals 1/100th. And to visualize that again, we're thinking about dividing up one thing into 10 pieces. 10 equal-ish in this case, pieces, right? So if this whole thing equals 1, each of these pieces is going to equal 1/10th, right? If this whole thing equals 1/10th, each piece is going to equal 1/100th. And then, still following this, if the whole thing equals 1/100th, you divide it into 10 pieces, each one's going to equal 1,000th. Okay? If we were to draw all of that out, right, we'd be able to see, oh, I'm taking each of my hundredths, I'm dividing it into 10 pieces, so 100 times 10 will give me how many total pieces I have, and that would be 1,000. That's why it's 1/1,000th. Okay? And the tricky thing that I've been noticing from some of your exit tickets and some of your work is a little bit of clarification is needed around how to name these decimals. Okay? If you have something like, I'll even give you a mixed number, right? Right? We have, I'll even scoot in closer here. Zoop, and zoop. There we go. So we have our whole number section over here to the left. We have our decimals section to the right. Starts with the whole numbers. So we have, in this case, just 6. Our decimal point, kind of the dividing line, 6 and. Then what we want to do is we want to look at the decimal by itself, everything to the right of the decimal point. Okay? What number do you see here? Yeah, 42. 42. And it is hyphenated in the middle. Then, in order to know 42 what's, you've got to think about how far along our decimal point, our decimal places, what's the furthest this number goes? Okay, and in this case, it stops at the hundredths place. So we're going to say 6 and 42 hundredths. Okay, so in essence, what we want to do when we're naming decimals is really to think about what number, what's sort of the total number that we know, that we see to the right of the decimal point, and then how far does that number go? How many places over? Okay, so if you have something like, we'll keep it at 0. Okay, just to make things easier, we can focus on the decimal point. And then we had something like, what would we call this number? What would we call this decimal? So first step, look at the total number, the whole number to the right. Not the whole number, but the complete set of digits to the right of the decimal point. What number would we call this? If it was a whole number, what would we call it? Right? 178. There you go. 178. And then, what's the furthest place that that decimal gets to? Okay, remember, there's an infinite number of places to the right. We just don't have any value there. So we don't need to worry about them. Okay, they're there only if we need them. This one goes all the way to the thousandths place. So you'd write 178 thousandths. And thousandth, just like thousand, but you throw a th on the end. Okay? If you wanted to look at that in fraction form, 178 thousandths. Okay? 3 different ways to write the same value. Okay, let's try another one. Maybe it's a little trickier. How about try that one out. So if that were a whole number, what would you call it? And then, what's the furthest place that that number gets to? All right, so here, yeah, 75. Okay, 75. That 0, again, it's just a placeholder because we don't have enough to make a full tenth. We only have 7 hundredths and 5 thousandths. Okay? Don't have enough to make a whole tenth. Right? If we wrote 75 as a whole number, we wouldn't have anything in the hundreds place because we don't have enough to make a whole hundred. Okay? Similarly here. We need our placeholder tenth there, however, to show which correct place our decimal lies. And in this case, it gets all the way to the thousandths place, 75 thousandths. Or, in fraction form, 75 thousandths. Nice, good. So now I don't forget the th in there. Right? The difference between 75 thousandths and 75,000 is quite significant. Right? 75 thousandths is here. 75,000 would be right? It's a difference of about, you'd have to multiply by like 1 million to get it there. 1, 2, 3, 4, 5, 100,000 to get it there. So big difference there. And you need that th in there to make it accurate. Okay, so 75 thousandths. Okay, let's do a couple more. And then I'll leave you to go to the exit ticket. Okay, kind of a quick one today. Let's try this. Ooh, let's go the other way. How would you write 2/1000ths. And again, that TH, very important there. That shows it's a decimal. 2,000 and 2,000ths are very, very different quantities. All right, $2,000 versus 2,000ths of a dollar. You can't even get 2,000ths of a dollar because that's like cutting a penny into 10 pieces and then taking 2 of them. What are you going to do with that, right? $2,000, you can do a heck of a lot with $2,000. So 2,000ths. How would we write this? So that's our key, is thinking about, okay, well, 2 is the only thing that is going to appear to the right. And then it gets to the thousandths place. So we're going to need to put it there. Are we done? No, we're not done, because look, we're missing some things. We need some placeholders to get us all the way to the decimal point. So that is what 2/1000ths would look like. And yes, we've got it in the chat. 2/1000ths. Excellent work there. Okay, one more that I do want to touch on, because this one, something like this could be tricky. What if you saw something like 600, well, I'm going to write it out in word form, 609 thousandths. $609 thousandths. So we know we're going to end in the thousandths place. Now let's think about that 609. How would you write out 609? Okay, and this one might help if you write it out as a whole number. Okay, so what would 609 look like? 600s, there's 9 ones, and we don't have any 10s, so we need a 0 in there as a placeholder. So if this number was going to go and end in the thousandths place, where would we need to start it? Yeah, because we've got 3 digits, and then we've got 3 places to the thousandths. So we can just start it right in the tenths. So 609 thousandths. And it looks just like that. All right. Nice, Ava. Nice, Alani. Nice, Fiona in the chat. Well done. Okay. That one can be tricky because, again, there's that 0 in the hundredths place, right? So being aware there. I would say one of the most challenging parts of decimals is keeping track of your zeros. Keeping track of where you need a 0 in order to accurately hold the place, right? If you have something like, 36 thousandths, okay, thinking about, okay, that 36, but it's got to end in the thousandths, so maybe I'll work backward. So it's ending in the thousandths, so the 6 goes in the thousandths, and the 3 goes next to it, and then, ta-da, we need a 0. We need zeros to get us to the decimal point, so every place is represented. Okay, otherwise we end up with 36 hundredths, which is 10 times as much as 36 thousandths. All right, exit ticket, very similar to this. You're going to have to name some. You're going to have to write some based on the name. All right, should be pretty straightforward. Remember, because it's conference week, there's no small groups this week for math. You are on your own, but I think you can handle it. I believe in you. If you have questions, Google Hangouts is there. Also, if you have questions, there's nothing wrong with just putting your best answer in the exit ticket, turning it in, and then I'm going to get a chance to look at it this afternoon and grade it and return it to you and get your feedback that way. Okay, so good practice either way. All right, thank you for joining us, everybody, in this look in the Thousandths Place. Reminder, at 11:30, we'll be right back here on YouTube for science, talking about solutions and concentrations today. So that should be a fun one. Quick turnaround back to YouTube today. So go try the exit ticket, take a little break, have a little snack, and then we'll see you right back here in about 45 minutes from when I'm saying this. All right, good luck, happy math, see you soon.